foundation for what was later to become the Ottoman Empire. As far as historians were concerned, the blossoming of Constantinople was the beginning of long-distance communication in this part of the world. But 500 miles from the capital, in the stark tundra of Turkey's Anatolian steppe, one of the world's oldest cities has something new to reveal. Çatalhöyük dates from the dawn of human civilization. It's the earliest city ever discovered, the first evidence of people living in a large, settled group. Here, 9,000 years ago, there were streets and houses with decorated walls and ornaments. A team from England's Cambridge University is slowly uncovering the city. For archaeologist Shahina Farid, this evidence of community living is a turning point in human history.
As a Neolithic site, the characteristics of Çatalhöyük is that it's one of the earliest sites when people settled down after a hunting-gathering type livelihood. And they settled down in one place, started building houses and taking advantage of their environment.
The city was supported by farming, and its people enjoyed a period of stability lasting many centuries. And they weren't just scraping a living. Skeletons buried beneath the houses revealed that these ancient city dwellers were well-nourished and healthy, apparently prosperous.
The community at Çatalhöyük appeared to have done very well at this particular site. The site was populated and lived in for over 1,000 years, and if things hadn't been working for them, they would certainly have moved on. So something was obviously keeping them at this particular spot.
So what was the key to their success? How did they manage the transition from nomadic life at a time when other groups had failed? As they considered this question, archaeologists at the site began to discover something unusual. Hidden in walls and floors, they found caches of a remarkable substance. It was obsidian, a natural volcanic glass. The people of Çatal must have brought it from the now dormant volcanoes of the nearby Cappadocia mountain range. Extremely hard and sharp, obsidian was a precious commodity, a perfect material for making arrows, knives, and even mirrors. The hidden caches of obsidian contained more than anyone could require for their own use. It looked as if the Çatal people were dealing in obsidian. But who were they trading with? Dr. James Blackman works in a nuclear laboratory, but he is in fact an archaeologist with a special interest in obsidian.
Archaeologically, obsidian is important because it was extensively traded throughout the ancient Near East, and it can be used to trace exchange networks.
There are only a limited number of sources for obsidian in the world. The people of Çatal had access to one of them. Yet in the last few years, archaeologists have been finding early obsidian artifacts in the Yemen and Iran, where no natural source exists. So where did that obsidian come from?
I use chemistry of the material to trace the trade. The first thing you need to do is to have samples of obsidian. Once you've established the chemistry of the geological sources, you can then match the chemistry of the artifacts found in the various archaeological sites.
And this is where the nuclear reactor comes in. Samples from all over the Middle East come to this laboratory where Dr. Blackman prepares them for chemical analysis. The samples are treated and passed into the nuclear reactor to be irradiated. The irradiated obsidian then begins to give off radioactive gamma rays that can be recorded and analyzed to give a chemical fingerprint for each sample. All samples from a particular source will share the same fingerprint. These chemical signatures allow Dr. Blackman to compare foreign samples with obsidian from Turkey. The results showed that the artifacts from Yemen and Iran could only have come from Turkish volcanoes.
The central Anatolian Turkish sources have been found as far south as the Levant and along the Euphrates River, and as far east as central Iran at a site called Tepe Yahya in south-central Iran.
Around volcanoes close to Çatalhöyük, there's clear evidence that obsidian had been extracted and worked. It seems that the Çatal people were processing obsidian and sending it on the first leg of a lengthy trade route. Perhaps this control over a popular commodity had accounted for their prosperity. These were the very earliest human settlements, and already a trade network was reaching out beyond the immediate area. Historians had thought of the Silk Road as the earliest Asian trade route, but the Çatalhöyük evidence totally overturned that idea. For the obsidian traders were plying parts of the very same route 7,000 years earlier. It was a revelation, and there were more to come. In the Indus Valley, in modern-day Pakistan and northern India, lie the remains of the world's largest prehistoric civilization. More extensive than that of ancient Egypt, more sophisticated than anything that came before and much that came after, the Indus Valley cities reached their peak about 4,000 years ago, 5,000 years after Çatalhöyük was built. For the past 10 years, Dr. Mark Kinowa has been studying the Indus Valley site at Harappa. Excavations here have revealed a large, solidly built city. Its brick houses, complete with bathrooms and water systems, displaying technology not seen again until Rome 2,000 years later. This was a typical, prosperous, peaceful Indus Valley city, part of a pattern of closely linked settlements.
The only way to really understand how they were integrated is through looking at their technologies, because the technologies were key to the movement across the Indus Valley and also the integration of those cultures.
In his work at the site, Mark Kinowa has built up a picture of a skilled and sophisticated people. They used a standardized system of weights and measures, and a writing system, one of the first, to tally their goods. It all pointed to trade, yet the Harappans predated the supposed start of the Silk Road by 2,000 years. The key to Dr. Kinowa's latest research lies with these tiny stone beads. They are found throughout the Indus Valley, and similar ones have been found much further afield. Mark Kinowa began to work on ways of identifying the origin of the beads. For him, the key lay in the technology used to make them. In his laboratory in the US, he has built a replica of an ancient drill.
This technique that I'm using here is based on a technique developed in the Indus Valley civilization, so around 2600 BC. The technique that I'm using here is using water to try to help cool the bead as it's being drilled. This keeps it from cracking, and it also cools the drill itself because the drill it gets very hot. It also washes out the ground up bead material that you're drilling out of this bead. One of the distinguishing features of beads is their technology in which they're made. So by comparing technologies, we can determine that beads that look the same are actually made in different places. And this is the result of looking at their drill holes and looking at the specific aspects of the techniques used to manufacture them.